This here is the source code for our simple video player. I'm gonna change here the speed to 1 so it plays at the normal speed. Let's check that it's still running. There it is. We can do something much more interesting than this simple video player. We already have video players in our computer probably. We can use the movie as a data source. In episode 115 I was talking about how the world is full of numbers. A movie is also full of numbers. And we can use the pixels on each frame of that movie as data to draw something different. And that's what we're gonna do in this episode. We're going to be doing something similar to what we did in episode 70. This is slowly changing the direction. I can run here the program and see what happens. So we're gonna be using the same formula as here. We are at a certain point in the screen, which is Alt X, Alt Y, and we're going to move 5 pixels away. So this number here is the distance, and we are going to move in a certain direction. The direction depends on this angle. So depending on how large this number is, we're going to go up or left or right or some other direction. So what we're going to do in our movie, this is our program, this is our movie. The movie has many frames. Each of these frames is arriving one by one to our program, and we were before just placing them directly on the screen. Now, instead of drawing this full frame here, now let's comment this line here. We're not gonna place the image, so we're not gonna do this. We're just gonna take a look at this image, and I'm gonna start at the center, the same way I was doing in episode 70. I'm gonna read the middle pixel, and I'm gonna check the hue, the saturation, and the brightness. And I'm gonna use this hue, this saturation, and this brightness as the values for this formula. So maybe we can use the hue for the direction, and maybe the brightness can be how much we move, and the saturation could be the size of dots we're gonna place. So we're gonna start placing dots here on the screen, moving until we reach one of the borders. To avoid that the drawing would start spinning here in the middle forever, then we can also set a limit. We can say that a maximum of 100 points. I'm not sure if we have taken a look at the break instruction, but I'm gonna show you this in a second. With break, you can stop any loop. So I'm gonna make here a loop, int I is 0, while I is less than 20, I plus plus, and let's print I. So I'm just gonna count up to 20. If I run the program, then it's outputting here all these numbers from 0 to 19. Well, there's a way you can stop the loop before this instruction is false. And you can do that with the break instruction. So if I type here, if I is greater than 3, then just break. And now the program will just stop when reaching this number. Of course, in this little example, it's quite pointless because I could have just written here maybe 4 and avoid this break. But in our program, it's gonna be useful here because we maybe want to draw up to 100 pixels, except if we touch the border. If we touch any of these borders, then break, then we get out of the loop immediately. Okay, let's get started here. First, I'm gonna set the color mode to hue, saturation, and brightness because I prefer working in this mode, and I'm gonna set that the maximum value for these color properties is 1 instead of 255, which is the default. Now, I said we're gonna start at the center of the screen, so let's type here int x is width divided by 2, int y is height divided by 2, and let's enter here our counter. So for int I is 0, while I less than 100, I plus plus. So we're going to take up to 100 steps from the center. Now let's read the color of this pixel, wherever we are. We are currently at the middle of the screen, so let's say that here int c is mauve.get. We shouldn't do just get, because get would read the color from here, from our display, but we don't want to read it from our display. We want to read it from our movie here. So I'm gonna type mauve.get, x, y. If you want to be very precise, maybe we should multiply these things by 2. Why? Our movie here is 2 times larger than our screen. So this is our screen, which is 640 times 360, and the movie is much larger. So maybe it's a good idea to scale this up so we don't read from the middle of our screen, but the middle of the video frame. Okay, so we're getting a color of the pixel in the middle of the screen. Now let's read the hue, saturation, and brightness. Int h, oh, actually it's float. Float h is hue of C. Float s is saturation of C, and hue, saturation, brightness of C. So now we have those properties. We can play now with those numbers. These numbers are between 0 and 1 because we have specified here 1. Just to make sure that this works, I'm going to draw an ellipse at x, y. And before that, I'm going to set the color fill HSB. I don't want the ellipse to have a border, so I'm going to say here no stroke inside the setup. So now it's a bit silly because it's going to draw 100 times the same ellipse, and I forgot the size. But okay, it's just to test that this is working. And I was drawing here this ellipse, and it should change the color as the movie goes forward. You can see that it's like a magnifying glass, just looking at 1 pixel in the middle of the screen. That's good, it's working so far. Now, first thing we can do is, instead of having a fixed size, let's use the saturation for the size. And the saturation is just a number between 0 and 1, which is tiny for an ellipse. So I'm going to multiply this by something, for example 20. So the size of the ellipses is going to be between 0 and 20. Okay, good. Now this should move. We don't want to have this ellipse stuck at the middle of the screen. So how can we move? We have to change x and we have to change y. Actually, we can use the shortcut. We could use x is x plus something and y is y plus something, but we can also write it shorter just by typing x plus equals and y plus equals and the formula we want to have here. X plus equals, we're gonna use sine and cosine. That was the formula. We're going to multiply this by a distance. Let's take a look at the old program from episode 70, and actually we were having this multiplication at the end, so I'm gonna write it the same way. Instead of multiplying something here, just to make it equal, it doesn't matter really. Multiply that by something, and that 2. So what value can we use? Let's use the brightness now. So the brightness is going to tell us how far are we going to move from one point to the next point, or how many pixels there are. Again, B is very small, so we don't want to just give tiny 1 pixel steps. I want to have bigger steps, so I'm going to just multiply this by 40. So this means that we're going to be able to move 40 pixels away. So from this point here, now in purple, we're going to go maybe here or here. Well, that's the maximum distance. If the brightness is less, then maybe we'll just give a tiny step. So brightness says the size of the step. Saturation says the size of the circle, the dot we're going to place. And now what's the angle? Let's use the hue for the angle. The hue specifies is this orange, yellow, green, red, blue. What is it? Again, hue here is very small, between 0 and 1. So let's multiply this by something. And I don't really know how much is a good value, but I'm just going to enter 15. If I would like to be able to turn exactly 1 turn, I should enter here 2 pi. But in this case, I'm not interested in being so precise. I want that the hue has a big influence in the angle. So I'm just entering here 15. You can try smaller or larger values. And I think we have just one thing missing in our program, which is to detect if we have reached one of the borders. The program probably works already like this, but it would be a bit more efficient if if we quickly go to one border, maybe then there is no point in trying to draw still out of the screen. So we can just add here an if statement. If x is less than 0, or is y less than 0, or is x greater or equal to width, or is y greater or equal to height. In any of those cases, which means have you touched one of the borders, then break, then get out of this loop. No matter what was the value of I, were you done here counting up or not, get out if you touch a border. And I'm going to set the value to 1, and let's hear what happens here. One final thing, I don't like the default background. I'm going to make it white. I have to set this after the color mode. Okay, let's see what happens. And it actually looks like this is sensible to the sound, but that's just kind of a coincidence. This movie has many different scenes with very different sound. And of course, each scene has very different images and sound, but this program is only reactive to the colors which are present in the pixels. 2 final tips. You might want to have a function. This is good to have always. Void key pressed, and then just save frame maybe. So this is good to have, that in case you see suddenly something you like, then you can press a key and you just save an image. Another tip for just optimizing to make this a little bit faster is it's recommended to not use get to get color pixels, but there's another formula which you can find in the reference. You can see here if we search for get, and it says down here that getting the color of a single pixel with get is easy, but not as fast as grabbing the data directly from pixels. The equivalent statement to get xy is pixels y times width plus x. So I'm going to use that instead. So here I'm going to replace this get by pixels. And now where I have y, then I should enter here y times 2, y times 2. And where I have here x, I'm going to enter x times 2. Let's see if this is still working. And we should see the same result, but it's a bit more efficient than before. So now you can do any kind of experiments. You don't have to use ellipses or move this way. The interesting thing, I believe, is to read the color of some of the pixels in the movie and do something with that. So you can get colors from pixels, read hue, saturation, and brightness from those pixels, and maybe move objects. Maybe you can set the position, or maybe you can set the sizes, the colors, different properties, depending on this data. You could even convert this into sound or into text, or just, there's infinite possibilities. Just try a few. Bye.